My name is LeVar Davis. I'm a Senior Applications Engineer for ATS Global in the North American region. Today we'll be covering some topics showing how you can get the most from your dimensional data. Some topics that we'll cover include how to consolidate your data and also supplier integration, using dimensional analysis to reveal hidden information, maximizing your data visibility, translating your quality metrics into savings, and then we'll just have a short question and answer session afterwards. All right, so in the manufacturing business, whether you're dealing with automotive, aerospace, or any other type, there's a high volume of dimensional measurement data that's collected during the life cycle of your product. And this measured data is vital in determining the quality of the product and the capability of your manufacturing process. But with such a high volume of data, a problem arises in that there's an interpretation that happens by your decision makers in your organization, and they have to go from the level of just raw data to the level of actual understanding before changes can be made to your production process. And of course, this takes time. The longer it takes to perform this analysis and spot the issues that affect your product quality, the greater to the cost to manufacture your product. That being the case, it's really in your interest to get the most information in the shortest time possible so you can successfully respond to any quality issues that appear. So then let's examine some obstacles that can prevent you from getting the most out of your measurement data, as well as methods to overcome them. So the first obstacle to quick response time is the difficulty of integrating the variety of data formats from your output devices. Of course, the use of different collection devices like CMMs, vision scanners, handheld gauges, and so forth are very necessary during the build process of your product. However, when you have such a wide variety of formats, it can kind of make it difficult to compare data. Also, important data that could reveal some key insight could be neglected just because it's not as visible as other sources or in a format that's as easy to understand or interpret. So one way to overcome these issues is to consolidate all of your relevant measurement data using a reliable data parsing tool which can upload your measurements into a common database. For instance, this is a measurement tool that comes with a CM4D package. This data parsing tool can take information from your various collection devices, and we can create parsing instructions which will allow this tool to pick up exactly where the information appears within the various file formats. So I see here I have a data parsing tool for Perceptron, there's one for DMO, there's one for laser, and there's one for handheld. And if you notice, the internal formatting of the data within the file are very different from each other, yet we're able to still accommodate the internal formatting and capture the information. This is done due to instructions that we create within this tool to define the placement of various pieces of data and be able to pick that up. So once this is done, the tool is created to make these translators once, and then information from your collection devices can be uploaded into one or more common databases from that point on, regardless of whatever it is you're measuring. So what are the major advantages of combining data from the multiple sources into one dimensional analysis system? Well, one advantage is that you gain a wider view of the variables that affect your quality performance. For instance, you can perform analysis across multiple filters, timeframes, locations, data types, and more, that depending on what data you have available within your electronic files to be tagged and used later on for sorting. Also, increasing the depth of your data is another advantage of consolidation. In other words, you kind of gain the ability to spot changes in your performance and understand the factors that contribute to that change. And if your dimensional analysis application supports automatic uploading in one or more databases, again, you ensure that the information is available to you and that it's consistently up to date and accurate when being used by your engineers and decision makers. So integrating external supplier data with your internal measurement data can be accomplished using the same method that we just saw with data parsing tool. If your analysis application receives data through file uploading, the source of those files can really be transparent to your system. So if you have a supply base send you measured data through, say, email or through FTP, you can integrate all that information into your system, regardless of your supplier's location or their time of operation. And once this is done, you can become aware of any quality issues that exist at the supplier level that could have a negative effect on your production. You could also assign rankings to your supplier based on metrics that kind of track their performance of their shipped parts. As an example, we have two reports here, which is tracking quality performance of about 5 suppliers. If you get your information, if they send you their data, either again through FTP or email or some means of entering into your dimensional analysis system, you could create reports such as these where you track their performance for all the parts that they supply to you on a weekly basis, which we see here. These are various weeks where data is being sent, giving you a percent intolerance for values that are intolerance, close to being out and out. And also we have a scorecard here which is showing the 5 worst parts or components being supplied to you from your various suppliers, along with the individual percentages for those components throughout the weeks. So another way to get more value from your dimensional data is to kind of create comprehensive reports that will help you see relationships in your data that might not appear on the surface. So there's a variety of software products that can help with this and can generate simple reports and calculate process control statistics. However, when nominal changes occur, the historical performance of your measured values could be masked if engineering changes are retroactively applied to your sample history. So let me explain what I mean here. Say, for instance, I want to look at or make an engineering change to a particular feature that I'm measuring. Well, like I said before, other engineering packages can have different chart types for you to view your information, like trend, histogram, Pareto, so forth. But if I'm interested in making a change to a particular point, say to some control statistics for this individual moving range chart, if I made a change to these control statistics, the change would, in normal circumstances, be retroactive for all the data so that my statistic calculations would kind of reflect that change as if it always existed for these points. But it might be more accurate for you if you're able to isolate those engineering changes. So for instance, I have some samples taken here on the 24th and the 25th of 2017. So let's say I introduce an engineering change where I want to change these tolerances. So that's 2017, September 24th, and I introduce it at 10 o'clock. And I can say that this is a process change that I'm entering here. Well, instead of having just one set of nominals that affect all my previous sample history, I can now have multiple sets of nominals which are isolated in time based on when those nominals are effective. So for instance, here I have a upper and lower spec limit for this one individual moving range dimension. I can add a new limit here. And after adding that limit, I see that I have two periods now, when the previous control charts were active and now when the current control charts are active. Doing that will kind of isolate the period when the most recent nominal changes have been introduced, and your statistics will be changed based on that isolation. So therefore you have a more accurate representation of how your part is performing or how your feature is performing based on these new limits or standards that you've added. Now, there's also value besides just creating historical limits. There's value in tracking the behavior of relationships between measured features. So for instance, I can show in this report, which is showing a body in white, there's individual values that usually get measured and are reported out. So in this case, I'm just looking at a single sample reporting on measured values on a body in white. But besides that, we can also report on relationships that might be valuable for you, where you're looking at maybe the distances between points. For instance, here I have distances in the X, Y, and Z direction, and I'm showing here within the CAD image the actual points that are involved in these relationships, and I'm seeing the distance between them all and the deviation within these main directions for those distances. We can also look at distances within trend charts as well, reporting out the deviations within the three axes, X, Y, and Z. And also we can do relationships between points that are showing maybe the range of values for a particular set of points. So I have deviations for this group, and what I'm showing here is the range for each sample of this group of points in the Y direction. So I have a flatness profile, so to speak, for these points. So tracking these kinds of relationships can reveal how your dimensional deviations relate to each other and how such deviations can affect the shape of your product. And this type of information can also help you determine maybe the functional priority of your deviations and decide which issues are most critical to your build process. Now, the measured data that you've collected can be mined even further to reveal how your parts could fit together before their actual assembly. This can be done by creating what are known as virtual alignments so that for your parts so that they kind of share a common datum scheme. So as an example, what I mean is that we can take individual parts that have been measured and predict how they would fit together by putting them all within the same alignment scheme and also adding the deviations from the values in one alignment to the part that fits on it within its own alignment, therefore seeing the total amount of deviations that exist for your points for a final assembly. So for an example, I have here a hood, hinges, and body. If I look at the body points that are being measured here, this data is from the CMM, but I can change the alignment of these points to be aligned to this hood opening. So to do that, I can create what's known as a virtual alignment, where I pick certain points within the 321 datum scheme, which will serve as my new datums. Once I pick those points and turn on the alignment, if you'll notice, certain of these values will zero out as they're being used as datums, and other points which are on this part will be recalculated based on that new alignment scheme. So I've just aligned this body. I can do the same for the hinges, but when I align the hinges, it can be based on the previous body so that the deviations stack up. So if I turn on the alignment for these hinges, this is the data that's aligned to the body, which we just did while it's in its alignment. And finally, the hood, we can do the same thing. We can have one part stack onto the other so that you can see if the deviations would accumulate if they're in the same alignment scheme. So if I turn on the alignments for all three of these parts, I get an end result here for my deviations, which would be far off, and maybe you wouldn't see compared to the actual CMM data that's measured for it. So you're seeing how the part would exist or how bad the deviation would be once all the errors add up from the previous alignments. We can even animate that here to show you in what direction those alignments would twist or distort your part. So we can see if you have the right tools, you can predict how your parts would assemble and fit together and show how the effects of deviations within one part can affect adjacent components. So all these examples that we've just shown show what valuable information is waiting to be discovered within your dimensional measurements if you have the analytical tools available to uncover that information. Okay, so far we've seen a few examples showing how you can get more from your data than what meets the eye. And these methods of mining your measurements can help your engineers on your quality team for sure, but they're not the only ones that can benefit. Your data can be used to create reports for those in other departments from the shop floor to management and can be filtered and presented based on their needs. That being the case, it's good to have at least one or two methods of delivering this information to those that need it within your organization. So one way of delivering information is to use BI tools like Power BI and Tableau, which can interface directly with a SQL database that might be housing your information or your dimensional measurements. So for example, we have here a Power BI report that's interfacing with the SQL database that has a large volume of dimensional measurements. And in this report, it functions kind of like a drill down interface where we look at overall percentage of points in tolerance for 4 car lines that are being produced at a plant. So let's say we want to look at this overall percentage of the quality of our parts. We can drill down and view the individual car lines that make up that overall percentage, as well as mean CPK value that exists for those car lines out of all the parts that are measured and built for the final assembly. With Power BI tools, it's easier also to change your percentages and recalculate data in order to reflect the accurate percentages and CPK values or what other statistic you want to report based on the sample history that you designate here. And if we wanted to drill down even further, you can arrange these reports to look at individual values and see its performance throughout its sample history to see how it's contributed to the overall percentage as well. Perhaps click through and see different features, and also put in, other charts such as Pareto or histograms or whatever you need for your reporting. So a dashboard interface like this is very flexible in its design, and it can be customized to fit the needs of your company or anyone that needs to see the data. And again, it can process statistics very quickly for thousands or even millions of samples. So this ability lets you examine the quality performance of your products from a bird's eye view and lets you drill down to areas or individual features if necessary. Now, another interface that can be helpful is a reporting portal that can house any reports that are created within your dimensional analysis tool. For the software that we have here at ATS, we have a reporting portal that can be configured to house reports from dimensional analysis tools. We can organize those reports based on security settings for users if you want them to have access to just certain types of content. And then in the report itself, in the portal, end users can choose from folders that have been predefined or set up and view reports that are generated by your dimensional analysis tool, and then click and view the contents of those reports. Also, we can set up search criteria or filters based on any information that you might receive from your sample files to help narrow down the scope of the PDFs that you're looking at. So the reports that are shown are constantly updated as the CM40 system uploads new data. So as that gets uploaded, new versions of these reports get created. So you're always looking at the most recent measurements within these PDFs within this portal. So then, how can we quantify and estimate how much we would save by reducing quality issues? Well, we at ATS have created a cost of quality and return on investment spreadsheet, which we can send to everyone attending. In fact, I think it's a download link that you can click on within this webinar. It lists certain areas of operation where cost reduction is possible. For example, maybe you can consider the amount of time spent in maintaining reports and other software packages or in Excel, or the time it takes to perform special requests for data and send that to requesters. And once you find the areas that apply to you, you can enter the appropriate numbers and estimates, and the spreadsheet will calculate monthly and annual savings. And it can also show you a 3-year return on your investment by taking the price of your dimensional analysis tool, compare it to your monthly savings, and you can see the total amount that could be saved during that 3-year period. So in review, we've covered data consolidation and integration, some useful methods of dimensional analysis, ways to share reports based on your data for maximum exposure, finally, how your data can help you increase your savings and production costs. So we have a few minutes left. Be happy to answer any questions about the information we've covered so far.
Okay, well, if anyone has got any more questions, there is the questions tab within your portal there. I've got a couple of questions already. Is CM4D supported in Europe?
Yes, CM4D is extensively supported in Europe. We have sales representatives and others within ATS who are there to support customers in the European market, as well as Asia.
Right. And can you provide pre-made templates to translate different data formats?
Yeah, we have a library of different templates, both for the data parsing for standard data formats and collection devices, as well as a library for standard report formats that we've created through the years in working with various companies in engineering and aerospace. Those can be accessed through a CM4D portal page, which we can provide a link to.
Okay. I've got a question here. Is the ATS reporting portal the newer version of WTC?
Yes, you could say it is. We've had a few other versions. There was CM4D Web. ATS reporting portal is a newer application which can replace some of the functions of both of those. It will be the, I believe, official reporting portal for ADOS software products, which includes CM4D, but CM4D won't be the only product to support it.
Okay, and then a couple of questions here about the kind of the speed of the product, I guess. Once data is entered, how long does it take to build a set of reports?
Well, to build a separate report, usually there's some training that's involved if we're working with the main module of the software, CM4D Classic. For that, it could take maybe 15 minutes, half an hour or so, depending on how much training a user has had. For another aspect, which is known as CM4D Interactive, reports are built automatically by clicking on a drop down to get a predefined list of chart types that you want. So depending on the application, it could be instantaneous, or it could take half an hour or so to build a report. Once it's done, however, and uploaded or published, that report gets automatically updated so that anyone who wants to view it will always get most recent data.
And do you need a powerful computer to run the CAD reports?
Not too powerful. Many regular laptops today can support the software. A lot of have graphics accelerators, which are more than enough to run the graphic component for the CAD images that you can see within the software. But we do have a requirements list for computers that want to run it. So if you're interested in the specifics, we can get that information to you.
And got the last one here. Is there a way that a trends box gets highlighted when a point goes out of standard on a set limit?
Is there a way trend point gets highlighted if something goes out of limits? Well, we can set what are known as conditional stylings for trend points, as well as for control charts for any data that happens to be trending up or toward a limit, or anything that violates any other control statistic. So we do have ways of changing the data markers if a point is out of tolerance or violates some control limit or behavior.
And I think I'm right in assuming you can also produce quality alerts, is that right? If they do go out of limits.
Yeah, there is an alerting aspect to the software where if, say, something gets out of a spec or maybe a statistic value that you're interested in drops below a certain number, we can have an email sent out to someone who's subscribed to monitor that behavior, and a copy of the report can be sent to them as well so that they can investigate the issue.
Okay, and that looks like all the questions.
All right, great. Well, I'd like to thank everyone again for attending. I hope the knowledge was communicated thoroughly for you and that you got something from this. Again, if you have any questions, you can contact me at my email or give me a call. I'd be more than happy to answer them. And I'd like to wish everyone to have a good day.